So are there any questions on any of the assignments thus far? Which are only 2, because we had homework for 7.1 and 7.3.1. We didn't cover 7.2. All right, if there are no questions on any of those two there, we'll go on and get started with the lesson today. Now, what we're covering today is dividing rational expressions. Now, for the most part, it's actually not going to be any different than what we did Thursday and Friday with multiplying rational expressions. The main difference is that when we divide rational expressions, two fractions, we're really just changing it from division to multiplication and flipping the second. So really, after that first main step, there's not any real difference than what we did yesterday. Not yesterday, Thursday, or Friday. So for any of these here division, we're going to change it from division to multiplication and flip the second fraction. And then just multiply and factor, or factor and multiply. Now there is a slight difference when we talk about restrictions. And I'll kind of show this with the example they gave here. Because when we talked about the restrictions on Friday, we really were focused on... So when we talked about the restrictions on Friday, we're really looking for what values of x would make the denominator 0. Now, if I picked x equals -2, well, as we can see here, -2 won't make either denominator 0. And if I plug it in, 7, -2 plus 1, divided by -2 plus 2 over 2 times -2 minus 3, we can see that both of the denominators here are not going to be 0. For the first one, we'll have 7 over, well, -2 plus 1 is -1. The other denominator, 2 times -2 is -4, minus 3 is -7. So in neither case, the denominator is 0. Now the numerator for the second one, -2 plus 2 is 0, yes? So what happens to the second fraction? Here, it becomes, well, the whole thing becomes 0, yes? But what are we doing now? We're dividing by 0. So when we talk about restrictions for division, well, we can't just have these here can't be 0. We also can't have the numerator for what we're dividing by be 0. So realistically, if we're talking about restrictions, what values of x we can't have, or things be 0, we're looking at all of this and, well, let me cross that out, this here. So for this example, the denominator of the first and everything we're dividing by cannot be 0. Because if any of this here becomes 0, well, we're dividing by 0. Because if the whole thing becomes 0, it does not work. So we'd have to look at a few more places for restrictions. Well, let's actually get into an example. So this will make a little more sense, and we'll see that this really is going to be almost exactly what we did Friday, except for one main step. Now, whenever I look at these here, these division, the first thing I'm going to do is change it from division to multiplication and flip the second. Because for us to be able to divide two fractions, well, we change it from division to multiplication and flip the second. So our first one's still going to say 7x over 2x minus 10. The second one is going to flip, so we're going to have x squared minus 11x plus 30 on top, and x squared minus 6x on bottom. Now from here, everything we did last week is going to be the exact same. Now we just need to factor, and once we finish factoring, we'll multiply and simplify. Now when we look at these here, well, 7x Won't factor because it's only one term. Since it's a single term, it's going to stay there. We can't do anything to it. Now, for the rest of these here, I'm going to look at the ones that I can factor the easiest. If it just has a greatest common factor or a difference of perfect squares are the ones I would want to mess with first or factor first. Now, looking at these here, which ones would be nice to factor first? So we can look at the 2x minus 10, because there's a greatest common factor of 2. So we can factor it out. And if we factor it out, 2 out of 2x gives us x minus 5. Because if I factor 2 out of 10, I'm left with 5. Now the other one's going to be our x squared minus 6x. We can factor an x out of both terms. And if I factor an x out of x squared, I'm left with x 6. Because if I factor an x out of 6x, I'm just left with 6. So those two weren't too bad because they just had a greatest common factor. So that leaves us with our x squared minus 11x plus 30 to factor. Now looking at this here, the 30 is positive, so the signs are the same, and they're going to match the sign of the middle term when we factor. So we'll have negative and negative. Now the factors of x squared are nx and x. Well, our factors of 30 are 1 and 30, 2 and 15, 3 and 10. 4 doesn't work, but 5 and 6. Which one of these do we think would most likely work? Or which ones do we hope would work? 5 and 6, yes? Because if I do 5 and 6, well, here I would have x minus 5, and here I'd have x minus 6, yes? If I use that, do I have something in common on top and bottom? Well, yes. So if that does work out, we do have things that would simplify. The rest of the factors wouldn't give us something that would, correct? Well, yeah. So what we can do, and a lot of it, this here with what we'll be doing, using the factors of what we have previously, or the ones that were easier to work with, kind of do help us find the rest. Now, if we did check this here, over here, if we did x times negative 6, it would be negative 6x. Negative 5 times x would be negative 5x, which does give us negative 11x, the middle term that we wanted. So those are the correct factors. Now at this point here, we can multiply the numerators and denominators. So on top we would have 7x times x minus 5 times x minus 6 over. Now we would move the greatest common factors to the front, so the 2 times x. Then we'd have x minus 5 times x minus 6. Now we can cancel out what's in common on top and bottom. So x minus 6 and x minus 6. We'd also have the in x minus 5 and x. Which just leaves us with 7 over 2. Any questions on any of this here? So for the most part, is this any real different than what we did last week with multiplication? No, we're just changing the one thing. Now, I do want to look at the restrictions for this one here so that y'all can see them, know what they are. And for the division, when we look at the restrictions, we're looking at the entire second rational expression, the divisor, if I'm remembering it correctly, and the denominator of the first one. Because we're trying to see what values of x is going to make anything in these spots 0. We'll make it 0. Now, we do have x minus 5 here, and we also have it here. So we do have it in 2 spots. And even though we do have it in 2 spots, that's only 1 0. We only have to list it once. And what value of x will make x minus 5 0? 5, yes? 5 minus 5 is 0. The other way we can look at it is it's set up as x minus 5 equals 0. See what value of x would make it 0? So you would add 5 to both sides, telling me x is equal to 5. So we also have x minus 6 and x minus 6. Well, for this one here, it would be 6. And we can do the exact same thing. X minus 6 equals 0. Add 6 to both sides, telling us x is equal to 6. And the last one we have is just x. And what value of x is going to make x 0? 0. Apparently I'm still going to write in a highlighter. And I mean, we can set the same thing up. X is equal to 0. Okay, so it's 0. And those would be the restrictions. And again, the restrictions are going to become more helpful when we start solving, because it's telling us what values of x it cannot be. So if one of these come up as the solution, it's extraneous. It doesn't work in the original problem. And it actually works out if all the solutions that we have are the restrictions, that means there are no solutions at all. All right. We can go on and look at the next one. Here. I'm going to go on and put the 2 lines down, because our first step is going to be to change it from division to multiplication and flip the second. So the first one's still going to be 11x over 3x minus 9. And the second one's going to be x squared minus 8x plus 15 over x squared minus 5x. So the first main step is changing it from division to multiplication and flipping the second. Now, if you feel comfortable with it, you could go on and change it from division to multiplication. Flip the second and go on and start factoring everything all in one step. But I wouldn't advise it, because that is a lot going on at once, and it's very easy to lose track of things or put stuff down in the wrong spot. Or I've done it before where I changed it from division to multiplication, started factoring, and never actually flipped it, and just kept it the exact same. So now that we have it set up for our multiplication part, let's go on and factor. Yeah. 3x and 9 do have a greatest common factor of 3 that we can factor out. And 3 out of 3x would be x minus 3, because 3 factored out of 9 leaves us with 3. I would look at the x squared minus 5x next, because it does have a greatest common factor of x. X factored out of x squared would be x minus 5, because x factored out of 5x would be 5. Now we need to factor the numerator. And what are we hoping one of those parentheses is? Well, I'm hoping it's either x minus 3 or x minus 5, because if it's one of those, we can simplify it down. Now, because the 15 is positive, the signs are the same, and they match the sign of the middle term, which is negative and negative, which is hopeful. Factors of x squared are x and x. Do we have any nice factors of 15? 5 and 3, yes? Well, that is really nice. Because even if we do check this here, we would get negative 3x minus 5x, which is negative 8x, which is the middle term that we want. So these are the factors. So now that we have these factored down, we can multiply them together. And again, whenever we have greatest common factors or terms by themselves, like 11x, we would want to move them to the front. Times x minus 5 times x minus 3 over 3x times x minus 3 and minus 5. Well, x minus 3, x minus 3, x minus 5, x minus 5, and x, and this leaves us with 11 over 3. It's not going to work out that every single time we will just be left with two numbers, like here 11 and 3. It's just worked out that these worked out that way. Questions on these here? Okay. We're going to skip this one here because if I remember correctly, this is going to work out to be, I think, 4/5, most likely. I want to look at this one here instead. Four a squared minus 1 over a squared minus 4 divided by 2a minus 1 over a minus 2. Okay. So the first thing that we'll need to do is to change this from division to multiplication. And the first one will stay the same, so we'll get 4a squared minus 1 over a squared minus 4. The second one's going to be a minus 2 over 2a minus 1. Now the a minus 2 and 2a minus 1 aren't going to change because neither one of these have a greatest common factor between them. A minus 2, there's no greatest common factor. 2a minus 1, there's not a greatest common factor. And the degree for both of these is 1. So it doesn't simplify down further. Now the ones we need to look at factoring are 4a squared minus 1 and a squared minus 4. Now neither one of these have a greatest common factor, but they are what? A difference of perfect squares, because 4a squared is 2a times 2a, and 1 is 1 times 1. So 4a squared would actually, 4a squared minus 1 would factor to 2a, 1, and 2a plus 1. And really where we put the plus and minus, which one goes first really doesn't matter. So I really could have had 2a plus 1 times 2a minus 1, and that would have been the exact same thing. It's really personal preference if you want to put the plus or minus first. In the bottom one, a squared minus 4. Well, that's another difference of perfect squares, yes? So it would be a and a minus 2 and a plus 2, exactly. And we have this here. Yes, ma'am. From this 4 here? Here? I wouldn't factor out the negative because, I mean, we could, which would give us 1 minus 4a squared, which would end up being 1 minus 2a times 1 minus 2a. And the one on bottom that we had is 2a minus 1. So we need the signs to be the exact same. So flipping it makes the 1 positive instead of negative, and the 2a negative instead of positive. So we need them to be the exact same for that to work. Because we could have done that, but we would also have to pull out a negative from this 2a minus 1, and then the negative and negative would actually make a positive, and we would be back to where we were before we factored anything out. So I would say a good rule for most of these here, with trying to pull negatives out and work with that, is if the variable is negative, the biggest variable that we have, so here if any of the two a's or a's were going to be negative, then I would pull it out. But since here all the variables that we have, the biggest variables in each parentheses is positive, I'm not going to mess with the negatives. If one of them we had, say, negative a squared anywhere, then I would pull out the negative. Does that kind of answer that question? All right. So we can write it again, or as I think I went over Friday, we can just draw a line and kind of connect the two and simplify out what's in common. We would have 2a minus 1 and 2a minus 1. Leaving us with and that would be it there. Any other questions on these here? Are you ready for the next one? Yes? We can look at this one here. I'm going to do one more of these types. Why don't you all go on and look at 43 in the next two and see if there's one of those that you all would like more than 43, 52, or 54. 54? Now the first thing, again, I would change it from division to multiplication and flip the second. The first is going to stay the same, and the second is going to become 16y squared plus 4y plus 1 over 4y squared minus 9. Now we look at the first two, 8y cubed minus 27 and 64y cubed minus 1. Since I do have cubes, y cubed, for the first two, I'm thinking there's a good chance it's a difference of perfect cubes. And if we look at these here, well, 2 cubed is 8. So if we took the cubed root of 8y cubed, it would be 2y. If we took the cubed root of 27, we would actually get 3. So that would be the difference of perfect cubes. 64y cubed, if we took the cubed root of it, would be 4y. And you all know what the cubed root of 1 is? 1. Luckily, 1 is the nice one to take any root of, because it doesn't matter what root it is, it'll always be 1. So the millionth root of 1 is still 1. So the denominator is also a difference of perfect cubes. So we have those there. So let's go on and do those. Small and big. And the bottom will also have small and big. Now our signs going across are going to be the same, opposite, always end on a note. And we'll worry about the second one here in a minute. Let's finish up with the first, and then we can move on to the second one. Now for our terms, we're going to have 2y. Here we're going to have 2y squared, 2y to the first, and then nothing in the third. Let's take those out and focus up here. Then we'll have 3 to the first, and 3 squared. And we could simplify that down in the next step where we actually simplify the squares in our multiplication. For our 2y times 3. You don't have to erase any of this here. I'm going to write it back. I am just rewriting it bigger. Hopefully that's easier to see. Now if we factor the denominator, we would have the signs would be the same, opposite, always ended on a positive note. For our first term, we'll have 4y squared, 4y, and then nothing for the third. And our other term is going to be 1 and 1 squared. Which is going to be the next one we would want to factor after this. And I'll actually give you all a second to finish writing that down. I'd be factoring most likely the 4y squared minus 9. Because 4y squared is a perfect square, because we can say 2y and 2y. And 9 is a perfect square, which would be 3 and 3. So 4y squared minus 9 would actually factor 2y minus 3, and 2y plus 3. Any questions over this here, Caleb? Okay. What are we kind of hoping with the 16y squared plus 4y plus 1? It'd be nice if it matches up to this down here. If it matches up with this here, we don't have to do anything with it. It'll cancel out. So let's leave it alone for now, because there's a good chance it won't factor anyways. And it does look a little funky, because 16y squared and 4 and 1. And since all the signs are positive, we're going to have to try to be adding the factors together. And there's not any two factors that of 16 that add together to give me 4. We'd have to have opposite signs. So if we simplify these quadratic parts of the sum of the difference of perfect cubes, so the first one is we have 2y squared. So we're going to square both the 2 and y. And 2 squared is 4, and y squared is y squared. 2y times 3 is 6y, and 3 squared is 9. Now, on a lot of these here in the homework, do make sure for like the 2y squared that you square both the 2 and the y. Now, in the denominator, I had a feeling it was going to do that. We have 4y minus 1. Now, the 4y squared, 4 squared is 16y squared, plus 4y times 1 is 4y, plus 1 squared is 1. Well, that did work out like we thought it was, because we end up having over here 16y squared plus 4y plus 1. 2y minus 3 times 2y plus 3. Now again, we're multiplying these all together. So a lot of times I will just go on and draw a line to put them together, because a lot of times I feel lazy and I don't want to have to rewrite this more times than I actually want to. Yes, ma'am. We'd have to multiply. We can't add them. Yeah, unfortunately, we can't do that since they're being multiplied together. We have the distributive property. It would be nice if it did, but unfortunately, it doesn't. We'd have to multiply, yeah. Now, these here would cancel out. The 2y minus 3 will cancel with the 2y minus 3. And that's actually it. So what we're left on top is 4y squared plus 6y plus 9 over 4y minus 1 times 2y plus 3. Now this is as simplified as it gets, because there's no way to simplify top and bottom, because the 4y squared, 6y, and 9 are all stuck together as a single group, and the 4y minus 1 and 2y plus 3 are stuck together as their groups. And that's it. That's all we have to do for this here. Any questions on these here? Now, I do know that there's more example problems on there, but I want to look at one last one, and then we are done for today. And we are done with 7.32. Now this last one here, the first main step is going to be the exact same. Now we change it from division to multiplication and flip the second. So our first one is still going to be 6x squared plus x over yes, because the denominator, if it's not given, is understood to be 1. If the denominator is not given, it's understood to be 1. So for here, when we flip it, the 1 goes on top, and the 3x squared plus 5x goes on bottom. Now, luckily for us, the 1 and 4x squared do not factor, so we can put them back in. Now, we can look at the 6x squared plus x minus 15, but I would rather look at the 3x squared plus 5x first, because 3x squared plus 5x does have a greatest common factor of x, leaving us with 3x plus, because we can factor an x out of both terms, and 3x squared becomes 3x, and 5x becomes 5. And that leaves us with factoring the numerator. Because the 15 is negative, our signs are opposite. One's going to be positive and one's going to be negative. Now the factors of 6x squared, well, the x squared would be x and x. Now the factors of 6 are going to either be 1 and 6 or 2 and 3. Which one do we want to try first? Well, what do we have already down below? 3x plus 5, yes? So if we want something to cancel, we need it to have a 3x plus a 5, yes? So over here, if this is going to work, well, I can put the 3x with the plus and the 2 with the minus to hopefully get something to match up. Now the factors of 15, the ones that are nice would be 3 and 5. And what I'm hoping is that the 5 would be positive and the 3 would be negative. Now if we do check this, 3x times negative 3 would be negative 9x. 5 times 2x would be plus 10x, which gives us a positive x, which we wanted. So that does work out. Now we can multiply and simplify. I'm just going to multiply together. 3x plus 5 times 2x minus 3 times 1 will actually just give us this here. I'm writing this out because if we look at the bottom, 4x squared times x is 4x cubed times 3x plus 5. And the only thing we have in common on top and bottom, 3x plus 5 and the 3x plus 5, which just leave us with 2x minus 3 over 4x cubed. And this would be it. Now, if you're able to do the multiplication and simplify from the previous step, that's fine. You don't have to rewrite it. But that is it for this here. Questions on any of this here? And